Perhaps the single most important thing to know about climate change is the amount of climate change we see this century is more or less proportional to cumulative emissions of carbon dioxide. That means even if by huge effort we bring emissions to zero in, say, 2050, we haven't eliminated the climate problem. Seas will still be rising, people will still be dying of heat waves. One of the big misconceptions about solar geoengineering is that it is an alternative, a substitute to cutting emissions. That's nonsense. It could be a complement. Solar geoengineering allows us to do something, imperfectly, about the risks of the carbon dioxide we've already emitted.
As a scientist, I'm not saying we should do solar geoengineering. In fact, I am quite terrified. But the key thing is that solar geoengineering has the potential for bringing real benefits for people and ecosystems compared to emission cuts alone. When you actually look at model results, these give some reason to assume that there could be utility in solar geoengineering. And in fact, one of my concerns why we need to do more research is that I actually think models, quite often in my opinion, make solar geoengineering look too good and too attractive.
The big question for Earth and atmospheric sciences is, how could we be wrong? These models might be in some way biased to make solar geoengineering look too good. And to examine that, we need to use all the tools of Earth and atmospheric sciences, from better space-based observations to aerosol microphysics and atmospheric chemistry to large-scale ocean and atmospheric dynamics. Unless we use those tools to really interrogate how solar geoengineering might work, to think hard about the ways that existing models might be wrong, to think about how to improve those models, we won't be able to develop any confidence about how well these technologies might work in the real world.
I am the principal investigator of the Stratospheric Controlled Perturbation Experiment, or SCoPEx, an experiment proposed by a team of researchers at Harvard University.
We're building a platform that will fly on a stratospheric balloon, and it will have a suite of instruments that's able to make some measurements regarding a stratospheric solar geoengineering. The first one is making some measurements of stratospheric turbulence. We want to better understand stratospheric dynamics of which these particles would be interacting in. The second goal is to understand particle microphysics. We want to know about particle coagulation, particle condensation, and if these particles were to be put into the stratosphere, we need to know how they would behave. The third goal is better understanding some of the chemical properties of these particles, how they react with the background stratospheric air, and what other kinds of chemistry consequences there might be.
SCoPEx is a small-scale experiment that will inject about 1 kilogram of particles into the stratosphere to generate a plume of a few kilometers in length that will have absolutely no physical impact on the ground. We've really been helped very much by this independent advisory committee that we have. They are advising us on the entire process. They are looking at technological readiness, they are looking at, does the science we propose make sense? But they're also looking at some of these governance questions and what the requirements are for SCoPEx to not just do the science, but actually do the science in the right way. And if we conduct SCoPEx in the wrong way, it actually may make it much harder for any other researchers in the future to actually work on this. And so this additional aspect of not only do we want to do our science, but we want to do our science in a way that's a good example for the future is both exciting and quite challenging.
The fact is, whatever opinions I and other people of my generation have about solar geoengineering, including people who think it should never and can never be used, we're not the ones who are going to decide. Our decision now is whether to study it seriously. And from my perspective, doing serious investigation of what its risks are and how well it could work provides the next generation with better information to make a more informed decision. It doesn't guarantee they'll make the right decision, but in my view, it's a duty to provide them with that information so they can make those decisions in the face of really horrific climate risks mid-century.
We need more input. We need diversity in people from different countries participating, people from different backgrounds, people with different perspectives, including very critical ones, because I think that will actually help to do better science and help us get more important research results.